Well, that's silly. I forgot I muted. Okay, so yeah. I'm sorry about that. Using namespace std. That's why I don't need to do std will. Otherwise, yeah. Include that's their version of import, I believe. I don't remember. So first things first is bubble sort. So we'll do void. No, public void bubble sort. We'll do int that array sorry. What's the issue? Oh, I think that's because it's not a class. And expected us. What do you declare? Give me a second. Something's not right. Let's say the issue is expected, declare array as argument. It's going to be let's try using system. What's the issue? No. Okay, that should work. Let's try this. Um, let's try that. Using system. Now, why is it going and doing that? I haven't had issues with that before. Well, this is where we need to... Oh, wait, hold on. Do that. No. Expected, int, or... Okay. Let's try the C# use, or... Oh, I'm so sorry. Let's try this. Int star or equals new int star, and I'm going to set it to be 50. Hmm? Array 1? No. Oh! Hold on. C#. Give me 1 second. I see the issue. I see the issue. Yeah. New project. Oopsie, new project. Sorting. Yeah, so, give me a second. Okay, so I see the issue. I'm not sure you noticed, but the extension was CPP, which is C++, not C sharp. So, yeah, that's the issue. Okay, so, okay, now let's get it. Public void bubble sort int star or r. Okay, okay, okay. It clearly wants it to be here. Oh, public. Don't want that static. Classes sorting. Okay, so C sharp print. So then you would do console.write line hello world. Then give me 1 second. I'll show you what it looks like. Yeah, see, it prints out hello world. So, okay, yeah. So let's get rid of that. So we're actually gonna do another thing. Public static for, no, not static. Public static int star generate random array. We're going to return, no, so int rand array equals new int. And what are we going to put here? We're going to put, let's say, let's pass it here, int size. Then we're going to do size. And see, why is this red? Because we don't return a value. Why don't we return a value? Because we don't have return. So let's do that now. Return random, and you'll see that goes away. So then we need random. So I'm going to have to import random, C# random. Import random. Oopsie. C# import random. I think we'll have to be using how do you import random again? Do I need to import it? Let's try this. Random rand equals new random. Oh, you don't need to import anything, I guess. Okay, so we're going to go, for, so a loop now, for int I equals 0, I is less than size, I plus, that loop. Then, we're going to do rand array of I equals rand.next, rand.next, and we're going to do a number, let's say 0 to dot max value. So what does this do? Let's explain. So we create a new random object, which allows us to generate random numbers. Then we do a loop for I equals 0, I is less than size, I equals, why is this? So let's say size equals, I don't know, 50. we're going to go through numbers 0 to 49. Because I less than size, as soon as I gets added and it's 50, it's no longer less than. Why do we do this? Because array indexes start at 0. So you'll have 0 through 49 in a size 50 array. Because this isn't one of those languages that indexes that one. Anyways. Now what do? We'll pick a number, random number between 0 and int.max value. Which, as you can see, is some giant number. Maybe we should make that smaller. No, that's fine. Yeah. So we could do, instead, size. No, we'll do int.max value, because we do not want that to, we don't want to multiply it by size in case they give us too big of a number. Anyways, return. So this whole portion generates the random numbers to be in the array. It will return that. So let's do this. We'll do int random array equals generate random array, and we'll make its size, I don't know. Let's say 30 for now. Then we'll do this. Can we pass that random array? What happens if we run that? Nope. Dot to string. Let me test that. Nope. So we would have to do for int I equals 0, I is less than 30, I plus console dot right, and we're going to do right. We're going to do that plus what is it? Random array. Nope. Random array. Let's copy paste. Random array of I. Random array. Yep. So we're going to do console.write, then that. We're going to copy that. And that. Then console.write line. So what does this do? Well, we're about to find out. Let's do another thing. Int size equals 30. Just to make things easier for the future. Though I could do length, but anyways. Let's change up here to be 50 for smaller numbers in general. Oh, right, okay. Actually, I'll show the console log. Oops. So let's open up Streamlabs thing. So yeah, you can see here it printed out the array. The thing is, there is this comma here. Why is that there? Because of this, we don't do a check, but it's fine. It doesn't matter. I could fix it, but it's just printing. It doesn't matter. Only if you want it to look nice. Anyways, so we know generating the random array works, and we will use this for all the other methods. Now, bubble sort will do. How does that work? Well, we're going to do... how it works is... I don't have paint. So let's say you have an array that's, I don't know, 3, 2, 1, 0. Well, it's going to check these two. It's going to compare which is bigger, then swap them. So in this case, it would swap because 3 is bigger than 2. Then we'll check these two. Then, since we will get 2, 3, 1, 0, it will check. Let's just it's bigger, so then we will get 3 here. Oops. 1 here. Check these two. That's bigger, so 3, 0. Then it's good. So then it's going to go back to the beginning and do the same thing. It's going to slowly swap, so bubbling them up to the end of the array. Now, there's the two implementations kind of you could do, depending on how hard you want to make it for yourself. The more efficient way, where you remember that this is already the highest, so you don't go that far, or the lazy way, where you just keep bubbling even though it won't bubble. So let's see. So we're going to implement this. Uses a for loop. So for int I equals 0, I is less than r dot length. I think we need that. No. I plus plus. Oopsie. Yeah, okay, that's fine. I think in Java you need that. But yeah. So that's good. So this will go through the array once, but we want to be able to go to make this work, we need to go through multiple times. So we need another for loop. So int what do we call y equals 0. Y is less than, we're going to go y is less than I think. No. Y is less than r dot length minus I. Y plus plus. Let's think this through. So we know if we have a size, let's say size 10 array, this will give us, so at position 0, this will give us array length, which is 10 minus 0, so we'll go all the way to the end. But if I equals 1, this will stop before the last element, which should be what we want. So anyways, now we're going to do this. We'll be using this outer loop is to get us through the array as many times as we need and to provide the length here. So anyways, what are we going, and this also gives us, I believe this is what we want. Wait, is this what we're scared of this for now? I'll figure it out. So what are we going to do? Yeah, what will we do? We'll we'll do an if condition. So r of I is less than r of y. Swap r, I, and y. But this doesn't actually do anything yet because we don't have this. But what's the point of this? Oops, semicolon. So what we're going to do is public static void swap, no, sorry, swap int r, then we'll just do index 1, index 2. Oops, sorry. Int index 1, int index 2. So, what does this do? Easy. This is going to swap the two positions in here. So we're going to do this. Int temp equals r of index 1. Why? Because we need to save them temporarily, the number temporarily. Then we will do r of index 1 equals r of index 2. So let's go over this. So let's say we had numbers 1, 2, 2, no, 0, 3, 2, 1. And we're trying to swap these two. Well, this part saves 2, so we'll get... No, it saves 3, so we'll have 3. Then we'll swap. So this will copy this value to this. And look, 3 no longer exists. So, but we need to place it here. That's how we do R of index 2 equals temp. So then we just copied the temporary value we set into here, and it swapped. So this is a relatively easy function. I might want to explain... No, this is sorting algorithms. I'm not going to explain this stuff here. So, we know the swap works. Now, the only thing to do is... we're going to do this. Bubble sort random array. Nope. Random array. Then we're going to do the same thing. So bubble sort, and we'll do this console.writeLine showcasing bubble sort. So let's run this. And this is where magic happens. You can see this was our array to start with. It's all randomized. Bubble sort sorted it. So you get 0, 0, 2, 7, 9, 9, 11, it's sorted. But this is, the problem is, this is a O of n squared sorting. So it's actually relatively slow. Like I said, we could, let me try to get this better. So I think we want this to be, let's see. I think we want this to actually be minus I. And this minus I. Let me check. Yeah, so we don't want to go to the end because the end's sorted. Then we don't want to go to the end because the end's sorted. Yeah, okay, so if I showcase this. Oops. Please don't. Yeah, so it's sorted. No, it's not. Why is it not sorted? Let me just check that again. Let me see. Yeah, I'm not Googling this algorithm. I'm going off memory. Y equals 0. Because I know we need to go through this multiple times, but we don't need to go to the end. It's this thing. Because I know we don't need to go to the end. Because it's sorted. Oh, but this we do need to go to the end for sure. Because in the inner loop we'll have to go to the end. Oh, I think this will be minus y. We control. No, that's not sorted. Wait, that's not sorting now. Do... So that try to minus I. Oh, that doesn't sort. You know what? Let's do bubble sort. Let's look on Wikipedia quickly. Let's see, Wikipedia says the bubble sort algorithm can be optimized by observing the pass finds the n. So the inner loop can avoid looking at the last n minus 1 item for running the n time. Yeah, that's not. Well, whatever. We don't need this efficient because it's inherently not good function. So what do we need? So that's bubble sort stuff here. We will keep using this method though. So we're gonna do this. Let's just oopsie, takes integer array and sorts it. Let's try that again. Oh, something's not right. Oh, I don't know what's going on with it. Whatever, it's fine. That usually works. So that's bubble sorting. And actually, just because public void print array, going to do array int array public print static void. We're going to take this. We're going to move it into here. Then we're going to do r.length. And array. What's this do? So we're going to print array random array. We can then get rid of this, showcasing bubble sort, and just do print array random array. And if we run it, let me put that up on the screen. You can see it works. Anyway, yeah, that just cleans our code up a bit. So actually, I'll call this bubble sort array. Do. So we're going to do the same thing. Bubble sort do. That's all nice. Now, there's another thing we can do. Showcasing sort will do. So the other thing we'll do is quicksort, I think. This one's more complicated, so we're going to do public static void quicksort int array r. Now, this is a recursive method, so how this works is it will call itself. If it doesn't make sense, don't worry about it, we'll explain. So let's see, how do we quicksort again? I'm trying to remember. Okay, so we need to do this. Let's do pivot. So we need a pivot point. We'll just use the beginning of the array, so that's fine. So we need an int start what's this? Start low equals 0. So let's do this. For int I equals 0. I is less than r.length plus. We'll go through it once. So how does this work? Let's do this. Int index equals 0. Final. Nope. Const int index. Yeah, that's fine. So that will never change. So start to low. Okay, yeah, that's fine. So if r of oh wait, this should start at 1. Whoops. Because we know index is fine. Okay, so if r of I, if it's less than or equal to r of index, then we'll... If it's less than or equal to, we just start low plus plus. So we'll just increase the value of where we know. Oh, I guess this is more. Let's just call it low. Yeah. So this is the final element where it's less than or equal to the index. That makes sense? Okay. Else. So now, if this isn't the case, if it's bigger, what do we have to do? Let's think this through. So if it's... Let's see, if it's smaller, it's fine, we just increase that value. If it's bigger... If it's bigger, then... I know we need to do a swap here at some point, so... Let's see. Oh, wait, there's one thing we need to do, actually. If... No, that's fine. Public static void. No, we'll actually do private. Private static void quicksort. Int r, int start, int end. That's... Don't worry about that. That's for later. So... Actually, what we're going to do is... This stuff we're going to stick in there. And I really wish this was Visual Studio Code right now, because that would be nice. So what are we going to do? Whoops. This is just going to call quicksort r0 r.length. Don't worry about this. This is just so you don't... When someone passes quicksort array to quicksort, they don't need to know this, and they don't need to know that. Okay, so we'll just call quicksort there. That's fine. So int low equals 0. Yeah, let me think. So we increase that. Index is the index. So if it's less than array of index, so if it's less than or equal to, we can just add that. But if it's higher... Oh, that's what I'm missing. That's what I'm missing, I believe. There will be a swap here. So else do nothing, I believe. Because if it's bigger, yeah, we don't increase it. So if it's less than low plus plus swap r I into low. Yeah, I think that's what we want, because let's reason this out. If we have, let's just do 9, 8, 7, 6, 5, 4, 3, 3, 2, 1. So, actually, let's make that in the middle, so that's 5. And let's make that 3, 4. Okay, so let's say we're looking here. Do nothing. Looking here now. Let's reason this out. So 5 is less than or equal to 5. So what do? We want to... So low... So where is low pointing? It's pointing here. What does this do? 5 is less than 5. So low will now instead point here. There. But then we swap. So that's 7. and that's 5. Yeah, that's what we want. That's the missing thing I was thinking of. Swapping. And since this does nothing, we can just delete that. Yeah, so that should work. So, what do we have? Oh, let's put that back. So let's assume the rest is whatever. 4, so then, sort into low half and high half. Now, what you're thinking, what do we do? That this is actually quite simple. We're going to call Quicksort again. So we're going to pass the array, but instead, what are we going to pass? We're going to pass... No, actually, we're going to say index start. Start. What's the issue? Let's just do that then. Expression passed to index must be constant. Oh, that's probably something to do with copying numbers, right? Okay, so we're gonna get rid of that const. Let's Google that. C#. Assign constant to copy of variable. No, you know what? Fine. Let's not use a constant. That's fine. So we're going to do this based on index, and I think it's low plus plus. No, low. Let's see. End. Oh, wait, no, this is wrong. I is less than end. And I equals start plus 1. Index. So why do we do this? Start plus 1, if in case it was started here. No, let's just do start. No, we do want the plus 1, so we don't do the index. Then if it's less than end, I post, but that's fine, that's fine, that's fine. So start will be the very first number. Then I just need to look at here. So I think we're going to want index, which is the start. Yeah, that's right. Into low. If low points here, it's less than end. So we passed length. So yeah, we want less than end. Then we just need to think here low plus 1 because low's pointing here. We want the end to be, yeah, that's right. Okay. So then, what else do we do? Well, we call this again Quicksort R, and then we want low plus 1 for start, and the end, we want end, I think, plus 1. And we just want end. Yeah, we just want end here. Okay, that's fine. So why do we call this twice? Because we split the array into 2 halves. So let's just say these were bigger than 5. So that's going to be 6, that's going to be 8, that's going to be 7, and that will be 9. So we split it into 2 halves, this half and this half. Then we will sort this. So that's the first part, sort the beginning recursively, which means calling itself, and, you know, we'll sort this end, and what we result with? A sorted array. So then we will, it's actually, since this is a void, we can just return. Yeah, we don't even need to return, so this was oopsie, what do you like to do? Whoops. Call it 5, so that's sorted. Hold on, let me do a copy. C# copy array. Let's see, Microsoft Documentations, clone. Okay, let's try this. Int star, what do we call it? Quicksort array equals bubble sort array dot clone. What's this say? Oh, hold on. I think what we want is quicksort array to be cloned. Creates a shallow copy. Oh. Let's see. Clone. Okay, so sorry. Hold on. Sort array to clone, and I think we do. No. The clone. Oh, that's what. Int. Let's see. That might have to be that. But that's a deep copy. No, that's a shallow copy. So no, that's probably fine. So then let's just print array of quick sort array. Let me just confirm that that's fine before I do anything. Yeah, no, that's fine. So, actually, I'll showcase it. So, give me a second. So, as you can see, this part, this is the bubble sort array. We sorted it. Then this is quick sort array, which is an exact copy of that. It's a shallow copy, not a deep copy, but there's no object, so it's fine. Anyways, hold on. Showcasing bubble sort. Can I change the print? Right. Console right line. No. Let's just do that. That make it look nicer. Yeah. Yeah, it does. Okay. So let's do. Actually, let's do this. Let's name this original array. So bubble sort, yeah, that's fine. Then let's copy that. Showcasing quicksort, but what do we need to do? Quicksort of quicksort array. So then we'll just mark that as quicksort. And this is the part where we kind of pray I did everything correctly. Okay, process is terminated due to Stack Overflow exception. Stack Overflow exception, C#. Okay, so oh, that's the issue. It's Quicksort. So, I actually forgot something really important, which is this is a recursive method, and each recursive method needs the exit condition at the beginning. So if start is less than or equal to, no, greater than or equal to end, return. Is that right? Greater than or equal to end. Okay, that's the issue. Low equals start plus 1. Process is terminated. Okay. Okay. So low equals start plus 1. That's right. That's equals start. Let's just do this. If true, return. Okay, so if start is greater than or equal to end. Okay. So I'll display the error I'm getting. Can I extend this? That's not really nice. Anyways, quicksort array. Index was outside bounds of array. Let's just do with that. Control F5. Okay. Start. So what am I doing? In theory, that should work. I'm doing something wrong, clearly. It might have to do with this. So index is the start. Oh, that's one thing I have to do, actually. I believe swap our index low. Move the index up. That is one thing I have to do. Yeah, I do need to stop that. So what is going on? What is going on? Yeah, why is this happening? So, let's see, index, that's the start. Maybe I'll just pass start here into low plus 1. What if I pass low? Nope, that doesn't help, so that should be low plus 1. I think. Low plus plus. Yeah, that should be right. It might have something to do with this. Oh, maybe the issue is low plus 1. No. That should be right, because if we pass the array.length, it should be less. If, this is where we would, hold on, debug. Let's see, debugging, Okay, so it's happening at the swap array index into low. Let's console.writeLine index. Oops. Index console dot right. Whoopsie dot right line. Actually, no, wait. I shouldn't. I should be able to just F5. What's the value of index? Int. Why is it not available? That's strange. Okay, let's stop that. So let's just do the standard console.log, no, right line, index and low. Console, one, do. So we're just gonna write index. We're going to write low. It's going to eventually crash for me. Oh, that's weird. That's strange. Give me a second. Why is that not happening? It's just going to 28. Let's see. Sorry, if this is the original array. Sorry. Okay, something's not quite right. Okay, why is it no longer printing? That's weird. Okay, so I'm doing something wrong. So low equals start plus 1, yeah, because we want it up 1. Oh, you know what? Let's just do this then. Let's just do that and see what happens. Stack overflow. Yeah, that didn't help. Index equals start. So array of index. If it's less than or equal to, then we add and swap. Start plus 1, so that should be... Let me... I have to think this through. So, assuming we have, let's say, 5 here, 9, 4, 3, 7, 6, 8. Here, let's see, low points here. Since that's higher... Oh, wait, this might be the issue. That's probably the issue there. Potentially. So, now low is going to point here. So let's go through. Yeah, I think that's the issue. So, this step. Going I equals start plus 1, which is this. It's less than or equal to index. Nope. So we're going to look here. It's less than or equal to index. Okay. So low now points here. Swap these two. 4 into 9. That's fine. Now we look here. It's less than or equal. So low points here. Will be 3 and 9. Nope. Nope. Let's say that was 1 actually. That means that will point here. I'll go to 1. 9. So let's figure out everything. So we swapped them. Let me just go to swap. Index 1. No, swap works. Swap works. Okay. So I think the issue is here. So what's the thing here? Start will be start, which should be here. So do start. Then low plus 1 is here. Is that correct? I think so. Let's do a size 5 array quickly. Yeah, okay, so, or no, size 8. Yeah, so I'm just gonna work through the debugging with you all. So this will help give, so, then, low plus 1 is here for that start, and end, what's end? It should have been the length at the beginning. Does end ever change? Actually. No, end changes here. So let's see. This will have a start of here and the end here. Then let's go through. Let's step through this. Ew, wait, that might be the issue. No, we did swap index and low. Oh, so this should go to 1, and that should go to 5. Because that part's important. I don't think swap low. Slow's pointing here. Oh, this might be an issue. Low plus 1. Yeah, okay. Let's do that at 30. See what happens. Yeah, okay, I fixed it. Let's show the terminal. As you can see, it's done. It sorts it. Okay, so the issue was, there were 2 issues for one. Actually, several issues. One, I never had this, which is really important. I did not do start plus 1. I said start at 0. I did not go to end. I did array dot length, I think. Anyways. I did not swap, which is super important. Then if you do low plus 1, oopsie, it terminates. Why does it terminate? Because, let's see, low plus 1 will just say go here. Oh, see, low plus 1 went to here as the end, when really we want here as the end. So low should be here. Why? Because we never need to sort this again, because it's in the correct position, because we know everything above is bigger than it. We know everything here is either less than or great or equal to it. So we don't need to sort that. So because we did that, this never really shrank, I believe. Or no, it should shrink, but pretty much we just kept going over and over again somehow, something like that. So anyway, so it works. So it works. That's perfect. But now we should time this. C# time. Let's see, C# time function. Execution time of a method. Okay, so let's do this. We will stop the printing of the arrays because, yeah. Oops. So let's try this. Yeah, okay, that's fine. We'll do this. What is that in? I don't know. Var start time equals environment dot tick count. Start time bubble. Bubble sort. Var, nope. End time bubble. So end time quick. Start time quick. Then we'll do just console.writeLine, and this will be run time of bubble plus end time bubble minus start time bubble. Let me just check that quickly. Then this should be end time quick, start time quick. And it says there's 0. Why does it say there's 0? Let's do 3,000. Oopsie, sorry. Runtime. Oh, wait, showcasing bubble. Why does it say that? Let's get rid of that. So, So for array of size 3000, we're going to just show the console. You can see bubble took 31. What's that measurement? I think milliseconds. But that's not all. That's probably not the best. We're going to tick count. There's also stopwatch. Um, let's try. Yeah, let's just try doing that to, I don't know, 10, 1, 2, 3, 4, 6. This will obviously take longer. Yeah, so let's see the how big is that array? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so will this finish bubbling sorting anytime soon? Yeah, maybe I'll just that. Let's knock off 2 zeros. What's the 1,000? 10,000? Okay, something doesn't seem right. 10,000, okay. And that's... Let's put that on the screen. So I'm just doing it. Wait, you can't see that. Okay, that's fine. So, yeah, it's just a waiting game, I think. Yeah, this is just waiting in. Since I'm live streaming, I can't just skip ahead. Oh, there we go, there we go. Yeah, so it took that many milliseconds. How many milliseconds is... I think it's 1,000 milliseconds. Seconds to millisecond. Yeah, 1,000 milliseconds in a second. So, as you can see, this took 1, 2, 3. That took 3 seconds, it says. And this took, well, that doesn't seem right, whatever. That took less than a second. Let's see. Let's see, C sharp flush to console. Oh, wait, that's the issue. Let's do that here. So let's do this. Actually, I think I want console.flush, it says. So console.out.flush. Yeah, why am I doing that? Don't worry about it. It's for a good cause, I'm telling you. Oopsie, I should show the terminal. So this seems to take much longer than the milliseconds suggest. Let me just do a Google. So C# environment dot pick count. No. Oh, see. It's much shorter. So actually, I'm gonna do a different method that I saw. So I think we want that. So what am I gonna do? Let's just do quicksort stuff. Okay, so stopwatch, quick, stopwatch, new stopwatch. So let's get rid of that for now and get rid of that. So, oopsie, that should be gotten rid of too. No, let's see that. So, let's see. Quick stopwatch.start. Bubble sort. Quick stopwatch.stop. Runtime of bubble equals. Gonna put that in here. Quick stopwatch dot elapsed. Then we're gonna do the same thing. Okay, we should be able to just call it stopwatch, I think. No, let's do it this way. That should be, oh, that should be bubble. do quicksort watch.stop. Runtime of quick. That should be bubble. Oopsie, control V. Let's see that. Oopsie. Yeah, let's pull up the console. Actually, millisecond may have been fine as well. Yeah, so all this is showing is, well, it shows bubble sort is bad. Like, it's fine for small arrays, but like this is only a size what 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Size 100,000 array of just integers, so comparison's really easy. And well, 1,000, 3, 1,000. Why is this taking so long? But yeah, it really shows that this is not efficient compared to Quicksort. Give me a second. Just a second, please. Yeah, this is taking forever still. Why is this taking forever? Something tells me it's not actually running for just those amount of milliseconds. Hmm. Yeah, this could be a while. Oh. Let's get rid of the console.flush then. Maybe that's the issue. Maybe that was the issue. Oops. Yeah, is there a way to time stuff maybe? It's not this? Yeah, oh, I have this timer, so it's been 1 second, 2 seconds, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I'll give it another 30 seconds now, and otherwise I'll Control-C this and see what's going on. Okay, something's not right. Console.writeLine not printing with stopwatch. Console.writeLine not printing C#. Okay, let's Control-C. Okay, so yeah, something's not quite right. Why is that? So let's just reduce that to 100 and Control F5. Yeah, that works. 1,000. Oopsie. 10,000. 100,000. Is that what I was doing? Hold on, Control-C. Let's just show the 10,000. If that feels like cooperating. Okay. Let's do this console.writeLine starting bubble sort. Yeah? Why? Let's delete these comments and just shorten up the whole thing. Oopsie, that's not what I wanted. Then it should be starting Quicksort. Oh, wait, somehow the comments seem to be interfering, maybe. Oh, let's see, let's give it... I don't know. Okay, why... Do I need to flush it? Yeah, okay. Why does this take eternity? Maybe I have to start Visual Studio Code. Oh, no, no. Give me a second to just restart Visual Studio Code. Not Visual Studio Code, Visual Studio. Maybe it's because it's 2017. Okay. Oh, something's not right. Okay. Screen capture. There. Let's just play the terminal. Okay, that seemed to fix it somewhat. Maybe. Let's give this until another minute. Because I really want to showcase just how bad bubble sort is. Yeah, let's give this 30 seconds. Otherwise, I might just have to take my word for it. Yeah, you can see this. Is it because I... Oh, wait. Is it because of this capture window, maybe? Control C. Okay, let's try that. Take that off. Let's not click anything. Oh, maybe it's just not playing nicely with OBS. Maybe. I don't know. Can I do logging? This is without debug mode, so it should be fine. Give it 30 seconds. Oh, it ran. Okay, it ran just fine. It might have been because of OBS then. There, see. As you can see, this took 27, almost 28 seconds for bubble sort. Quicksort didn't even take 1 second. If that's how I'm reading it. Yeah, I think that's correct. So bubble sort, not even 1 second. No, bubble sort, 28 seconds. Quicksort, maybe a second. So, yeah, use quicksort, not bubble sort. It's been almost an hour and a half. I could, maybe I'll continue this later, but you can hide quicksort, because we know it works. Hide bubble sort, because we know it works. Hide swap, hide print array, and hide generate random array. Actually, in that case, I'm just going to do. Yeah, okay. Oh, wait, maybe it had to do with that stuff generating the stuff. I don't know. No, it shouldn't have. Anyways, so maybe we have time for merge sort. Public static void merge sort int do r. We're going to do the same thing. Public static void merge sort int r int no r int start int end. Now why is it not liking this? Oh, there. And let's see, merge sort. All right, this is the weird thing. So obviously, if start is less than end, if start is greater than or equal to end, return. That's the base case. So into this, we're going to merge sort r0 r.length. Yeah. So how does this work? This one's simpler. Sort to halves. Int end index equals, let's do end minus start divided by 2. And let's do math.floor just in case. Oh, it's, no, we don't need that. Okay, that's fine, that's fine. Now, let's see, we're going to call merge, or, no, int merge 1 equals, how do we do this? Merge sort r start end index. What's the issue? Oh, I see. That's the issue is... No, this is fine. Merge 2 equals r, then end index plus 1, and end. And then, so we're going to merge so let's do this. Int star merged array equals merge 1, merge 2, return merged array. Oh, wait, that's the issue. Public static int star. Return void. No, just return R. There. That's what we're going to want. Oops. Merge. Then public static int merge R1, R2. Actually, that should be private. Because we don't want people calling this outside the class. That's fine. So merge. How does this work? Int merged array equals, in this case, it should be new int, then I think r1.length, r1.length. Oh, I'm an idiot. Int there. So r1.length plus r2.length do return merged array. There, so let's see. If this is 0 and 1, and this is 2 and 3, length equals 2, length equals 2. Yeah, so that is right. Okay, that should be right. So then how do we do this? So we're going to go for int I equals hold on. Int r1 index equals 0. Int r2 index equals 0. For int I equals 0, I is less than math.min r1.length r2.length I plus plus. So why are we doing this? Because we don't want to go out of bounds on the index. So so we're going to do this. yeah, we're not going to use I, actually. We're just... So, if R1 index is less than or equal to R2 index... hold on. So, int index, merge index equals 0. What are we going to do? We're going to, out here, we're going to do merge merge index plus. Then we're going to do, so in here, if it's less than or equal to merged array, merge index equals, what is it? Oh my gosh, that's why. Merge, not marge, okay. Equals, so if it's less than R1 of R1 index, then R1 index plus, else, so merged array, merge index equals R2 index, R2 index plus. So this will merge it fine, but eventually we may hit a part where one array is larger than the other, or pretty much there's leftovers in one array. So outside here, we're going to do if R1 index is less than R1 length, if R2 index is less than R2 length, what are we going to do? For I equals, well, for, let's do a while loop. While R1 index is less than R1 dot length, R1 index plus, and merge array, merge index equals R1 of R1 index. Then here, merge index plus. Actually, we could probably get rid of the if. Oopsie, so let's just do. Oopsie. Sorry. Yeah, that's fine. Let's just copy paste and just change some numbers around. So while R2 index is less than R2 dot length, R2, R2. So yeah, because this is pretty much an if condition, so it should be fine. Return merged array. Okay, that's what we want. That's what we want. Oh my gosh. Okay, so finally, return merged array. So int star merged array equals merge sort. Then can I just copy this? Can I just copy this like before? No, I have to manually copy. Okay, so for int I equals 0, I is less than r dot length, I plus r of I equals merged array of I So let's try that. Int star merge sort array equals int do, and then bubble sort array dot clone. Then let's just copy that for merge sort. So merge, starting merge, merge stopwatch. So then do merge sort array. Let's try running. See if there's issues. Stack Overflow exception. Yeah, figures. So let's just do let's just take that stuff out so it runs quicker. Okay, so what's going on? Probably has to do with my merging. Let's just F5 to debug. Okay. Sorry. What's going on? Start and end equals. Okay, so print array r. Let's do that. Oh boy, that's not what I want. Oh boy. Let's do, okay, let's just, so int size equals 10. Sorry. I forgot a semicolon. That's fine. Okay, I'm seeing some issue here. Merge should be fine. Merge sort if starts less than end. Okay. Oopsie. Console.writeLine start console.writeLine end. Two and one. Okay. Let's just do this. If it equals end. What is going on? Return array. Oh, I bet it has to do with this stuff. So end index. It has to do with this. I guarantee it. So let's think this through. Start should be 0 and let's do this. Console dot print write line and index. Oh, what? Okay. Okay then. So, hold on. This should be start do plus end plus do half. So start is 3, end is -2. Why? Go to the really beginning. End is 5, then half is 5. So start 0, end is 5, half is 2. Oh, wait. Okay. I think I see an issue. Maybe. Let's try this. Plus start. Let's get rid of that. Let's get rid of that. Oh, wait, where's printer 8? No, I don't want that. Let's go back to the timing. Do. Oopsie. Do. Okay. So let's go back to, now that I fixed it. Starting Quicksort. Starting Merge Sort. Merge Sort's running a tad slower. Yeah, it's probably because I didn't program this quite nicely. Because I created new arrays, I copied stuff over, blah blah blah. On out of memory exception. What? Oh, I see. Okay, no, it's fine. Let's just reduce that to 10,000. Let's take a look at my memory, actually. Yeah, I see a thing going on. Yeah, that makes sense. That makes sense. So on Task Manager, my memory was going to 1 gigabyte about. So actually, let's just show the console. It does run just about as quickly. Hold on. Runtime of merge. Yeah, okay. No, but it does run just as quickly, essentially. Let's just do that again. Quicksort, merge sort, do. I'm merge sorting, right? Okay. You can see merge sort's running pretty quickly as well. Pressing continue. So what was the issue? Let's see. I needed this plus start. Let's go over why. When it has to do, so let's say start equals 3 and equals 5. 5 minus 3 equals, no, 5 minus 3 divide, so what's the middle of them? 4. But divide by 2, what's that equal? 1. So we were getting our indexes all messed up. But if we do the 1 plus the start, which was 3, we get 4, which is the correct. Oopsie. Which is the correct number. So, yeah, you need this. You need to just get the average. There's probably a function for that. C# get number between two numbers. How do you get the number? Get average of numbers. There's a, let's see. Yeah, whatever. Just do this. That's fine. So you see how merge sort works. So let's go over it again. It has two important components. Calling merge on one half, merge sort on one half, and merge sort on the other half. That will return you new arrays, or it will sort them, and then you merge them. So I went with the easy route of just creating new arrays, because merge sort. Merge sort is also known as heap sort because you move everything to the heap memory, you sort it, and then you merge it all and you return a new array. So yeah, this one's really simple to do. The biggest part is the merge function, which, as you can see, is quite noticeably larger than merge sort. What about quicksort? This thing. Wait, we can delete that. Let's delete some stuff to shrink it down. The important thing is you call quicksort on one half, quicksort on the other half. The important thing on this is this part where you pick an index, you move the low numbers to one end, high numbers to another one. And so you're probably wondering runtimes. So let's go over this. Runtimes. Bubble sort is big O of n squared. What does that mean? Pretty much as your array gets larger, your runtime gets exponentially bigger. So because you could see because of this dual for loop, that's a big way of telling. So yeah, so that's why it's O and squared. So exponentially bigger, so you don't want those kind of functions in general. What about merge sort and quicksort? Merge sort / quicksort. Let's do that. Nice. They're big O of n log n. What does that mean? Well, you have one pass through, so n, it's linear. As your array gets bigger, it's linear time times log of n, which why log n instead of n squared? You're wondering, it's because of the recursiveness, where it does grow, but not as much because you call less and less. So one half, smaller half, smaller. I don't remember the exact details, but it is big O of n log n. Now there's also just for the fun, I think it's called random sort. That's big O of, well, give me a second. Let me pull it out if I can find it. Oh, why can't I find the thing? I will find the little thingy eventually. Windows period, don't fail me. Oh, you know what? I'm gonna Google it. What is this big O of? You're wondering? Infinity. Why random sort? What is it? Well, it's essentially this. Is array sorted? Yes. Done. No. Sort randomly. We'll sort again. How do you sort? You just mix up the numbers and yeah. So that's a fun one. It's not a real sorting algorithm. Do not use it, please. It's not going to work. I mean, it could work. It could be O with n, but no, it won't. Let's just no. So some disadvantages of Quicksort. You'll notice I took the easy way, and I said the index equals the start. So why is that bad? Let's make this a bit better. So rand equals new random. Then swap our index rand dot, nope, we want rand dot new dot next, and this should be start and end. Let's try that again. Merge sort takes eternity. Seems I don't trust that, but probably wondering. Okay, so why this? Because Quicksort has a funny little quirk. Where it actually average runtime is n log n, but worst case is n squared. Merge sort is always n log n. Why is Quicksort all potentially n squared? And it has to do with this index and bad indexes. So let's go over here. Let's just write infinity in case it doesn't like it. So let's say you have sorted array 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, blah, blah. Let's say you pick this index. What's the issue, you're wondering? Well, nothing's greater than or equal to it, so we'll call sort on that small half. So 0, it's sorted, whatever, and then we'll sort everything else. Whoopsie, what's that? Whatever. What's the index for that next pass on that half? Here. That's not good. That's not good at all. Because then we have that giant thing and it's going to be n squared. Because you're not actually shrinking them. Because the important thing is you want to get about 2 equal halves. But sorted arrays, nope. What about reverse sorted arrays? Same issue. Everything will be on one side and only one thing on the other. So, why does my fix work? Well, it's not my fix, it's what I learned in class, but you randomly pick something and you, let's say it's sorted, you might pick here. Well, you'll get this, and then for this pass, you might get, I don't know, 2, and here you might get, let's say, 8. Pretty much because of randomness, it averages, it should get the middle enough of the time that you get approximately 2 equal halves. Is it possible for it to always pick the worst index? Yes, if it's like a random array and it just keeps grabbing the worst index, it is possible. It's not likely. What is more likely is calling Quicksort on an already sorted array. And in that case, picking the first index or the last index is the wrong thing to do. So pick random indexes. And oopsie. So let's do that. So let's get rid of the stopwatch stuff. Does that run a bit faster without the stopwatch? Yeah, it actually does. So console.writeLine finished. Oops. Finished. So let's do that. No, that's gonna crash my memory. So it's let's see, starting merge sort takes a bit longer because of creating elements. I'm not sure why it says it takes the same amount of time. And it's already done. just like that. So my glasses are dirty. Let me just clean them. Maybe, yeah. So that is an important distinction, that for Quicksort, you need a random index because you're more likely to call it on a sorted array than anything else. Merge sorted doesn't matter. It will work. So there's another sorting method I won't go over. It's not as efficient. It's unsquared. What was it? Swap sort something? I don't remember. But there's a implementation of Quicksort where you would do a check. Okay, if let's say end minus start is less than, I don't know, 6, let's say. Yes, swap sort. No. Oopsie. Let's do that. Yes, no. No Quicksort. So why? Because Quicksort, because of the way it works, I believe it gets on really small arrays. The difference between them isn't as between, let's say, bubble sort and Quicksort isn't that big if it's like less than 10 elements. So, but Quicksort does the additional work of splitting it off, doing all that. So with a small enough array, this swap sort could actually run faster. But so I believe it's in the Python sort library. It implements it, something like that. Don't quote me on that. I could be wrong. That's what I was told in class before, when I was still in school learning programming. Yeah, that would. We don't speak about how long ago that was. Anyways, so yeah, so Quicksort and merge sort, the best sorts. Merge sort, if I implemented it correctly, differently, there is a way to not have the new arrays, I believe. Yeah, there should be a way to implement it without creating new arrays, copying stuff over, blah 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 blah, like that. But it's fine, this implementation for now. Just causes out of memory errors if I do too big of things. But it's fine. Anyways, that's the sorting. So, oh wow, it's been 2 hours about. Anyways, let's call it done here. Okay. Well, you got to learn some programming. Maybe I'll do another programming stream again in the future. Thank you, everyone.